Introduction. Every time we move something, use our pencil or walk, we are using force. Think about how many times you would lose your papers if inertia didn't make it stay where you put it. Objectives. At the end of this lesson, you'll be able to define force, distinguish between balanced and unbalanced force, Newton's law of motion, relation between force and the state of motion attained by it, understand the conservation of momentum, force and its types. The object will undergo change in its direction, speed, or shape only if force acts on it. Hence, force is defined as: force is any influence that causes an object to undergo a change in speed, a change in direction, or a change in shape. Force is a vector quantity. Force is of two types, balanced and unbalanced. Newton's first law of motion. The book will not move by itself. It will change its state of rest only when force of hand acts on it. This explains us the first law of motion. First law of motion states that a body will remain at rest and a body will remain in motion until and unless external force acts on it. Application of Newton's first law of motion. When a bus starts suddenly, the passengers fall backward because of inertia. The passenger tends to remain in the state of rest even if the bus has started moving. Inertia is the property of the body due to which it resists the change in its state of rest or of uniform motion. Mass is the measure of the inertia. Newton's second law of motion. Newton's second law of motion states that the force acting on the body is directly proportional to the mass of the body and acceleration produced in the body in the direction of the force applied. F is equal to m into A, where F is equal to force, m is equal to mass, A is equal to acceleration. Unit application of Newton's second law of motion. Cricket player lowers his hands along with the ball to catch it because the acceleration of the ball gets reduced and hence overall smaller force is applied to stop the ball and no injury is caused to the hands of the player. Momentum. Momentum is mass in motion. P is equal to m into v, where P is equal to momentum, m is formulation of second law of motion. The change of Newton's third law of motion. Whenever one body exerts a force on another body, the second body exerts an equal and opposite. Examples to illustrate Newton's third law of motion. How do we walk? When we walk on the ground, our foot pushes the ground backward. Assessment. Law of conservation of momentum. When two or more bodies. Did you know? Summary. Let us summarize what we have learned. First,